practice problems in the back of this note package. If you haven't already watched the video on the notes in which we filled out a lot of the main ideas and talked about some of these definitions, I would really encourage you to take some time to go through and watch that video. If you feel like it helps, you can scrub through some of it. If you aren't interested in watching me highlight, for example, you can judiciously skip forward. But it's going to be really hard for these questions to make sense if we haven't gone over some of the main principles. And I am not going to be, when explaining these solutions, taking a ton of time to explain what I did explain in the notes, where we went over a few of these examples. Okay, with that aside, let's get started. Okay, so first question, pretty straightforward. We're asked to state the properties of the graph of each sinusoidal function. So when we say properties, what I want to know for question A is I want to know the amplitude. I want to know the, what do I want to know? The period, which is T, A. I want to know the phase shift. And I want to know the vertical shift. And phase shift is given the Greek letter P, phi, and K. Okay, so this is pretty straightforward. This has an amplitude of 2. Period, okay, so we know the B is 4. This is not the period, right? So we got to remember that our period is equal to 2 pi divided by our B value, which means our period is equal to 2 pi over 4. So that simplifies, so our whole period is equal to pi by 2. I'll just maybe put these in boxes so they're easy to check in the PDF. Our phase shift, we can read here, is going to be positive pi over 6. That's phi equals. And our K value is 5. So our K value is 5. All right. So I'm going to abbreviate that a little bit for the next steps, because I think parts of question 1 are pretty straightforward for you guys. All right. Now question B. Our amplitude is 1/2. So the fact that it is negative, it's true that it has been reflected, but that does not affect the amplitude. Amplitude is a positive property. Our period is equal to 2 pi over our B value, which is 2. So that means let's put that in the box, our period is actually equal to pi. It simplifies to pi. Looks weird when I write it like that. All right. Our phase shift. So we can imagine this really looks like a negative, or we're subtracting a negative pi by 4. So our phase shift is a negative pi over 4. And our K value is negative 3. Okay. So, moving on to part C. So we have 3 sine of a half of x. So it can be helpful sometimes to rewrite it in terms of, we can put zeros and ones wherever the terms that aren't represented would be. So it'd be x minus 0 plus 0. Okay, and maybe that helps us recognize that our a value is 3. For our period t, we know that it's equal to 2 pi over our b value of a half. And 2 pi divided by a half. That's like saying 2 pi times 2 over 1, which is 4 pi. So our period is equal to 4 pi. And as you can see, our phase shift is 0, and our K is also 0. Our vertical shift is also 0. last one from this section. So I'm going to, again, rewrite y equals cos 1/3 x plus 4. I'm going to rewrite that as y equals 1 times cosine of 1/3 of x minus 0 plus 4. And that helps me see that my amplitude is 1 in this case. My period is, again, is 2 pi over my b value of 1/3. And that really becomes, that's the same thing as saying 2 pi times 3 over 1. Oh, am I off screen? I am. And so that means our period is equal to 6 pi. We have a phase shift of 0. We're not moving it left to right, and we do shift it 4 units up. And that is it for question 1. All right. So question 2 asks us to fit a cos function to this graph. All right. So we went over some useful tactics for approaching a question like this. Step 1 is we should write out a general cosine function. So y equals a cosine b x minus phi plus k. And we're going to pick these off one at a time. I find usually the amplitude is the easiest value to pick out. So first I'll try to locate the midline, which I can see to be right here. And the amplitude is the distance from here to here. And I usually find I can usually read an amplitude right off the graph. So for my amplitude, I'm going to rewrite it as y equals, I can see that it goes up to 2. 2 cosine b x minus phi plus k. Okay. Then I'm going to say, how long does it take for this thing to repeat itself? So I could go peak to peak if I like. Find the vertical value of the peak, horizontal values of each of these peaks, subtract them. And that's fine. However, I can also see that it repeats right on the axis, very nicely in the middle here. So it starts repeating after exactly pi units of distance. So I can say that for the period, that's pi, or no, t. Okay, so we'll do it 2 ways. First, I can just read off the graph that it starts here, going upward, and when it comes back to the x-axis, it's actually going downward. So I wouldn't say it's quite repeating the same exact properties, but when it hits the x-axis the next time, it actually is rising the same way it was initially. So I can say that these two are points at which the graph starts to repeat the same pattern. So I can say that t equals pi, and then I can say, well, b is equal to 2 pi over t, so b is equal to 2 pi over pi, so my b value is 2. Okay, so I'll take that value, and I'll say, really, my function could be rewritten as y equals 2 cosine 2 x minus phi plus k. All right. I think I'm also going to write out here that another way to have thought about the amplitude, if you weren't sure, is to look at the max height and the min height. So you can say max minus min, and you can divide it by 2. So that is 2 minus negative 2 divided by 2, which is 4 divided by 2, which is 2. So our amplitude is our max minus our min, And I can highlight those. There's my maximum value up here. My minimum value is down here. All right. So next I should probably start with my k value. I find that's usually pretty easy to find. My vertical shift. And it looks like this function has not been shifted upward or downward from a normal cosine function. Its midline is on the x-axis, just like a regular cosine curve. And I can refer back to my original cosine curve that we did in our notes. And I can say, well, yeah, it looks like this guy's midline is also along the x-axis. So I wouldn't say this new graph is shifted up or down. So my k value is 0. So that means I can rewrite the equation y equals 2 cosine 2x minus phi. And I'm not even going to write any plus 0. So now I just need my phi value, and then I am done. All right, so my phase shift. All right. So again, in a cosine curve, we want to ask ourselves, where does a normal cosine curve start? And normal cosine curve starts at 0, 1, and it starts going down. So really, it starts at a peak. And so maybe the peak on our graph also hits the y-axis, or maybe we can think of it being shifted to the right or shifted to the left. And we look and we see our peak is not on the axis, it's over here. So it looks like this thing has been shifted to the right. Use red already, I'll use green. Shifted to the right. The question is how much? What is the horizontal shift, the phase shift in other words? That is phi there. Okay, so I should probably figure that out, and I can see that here is pi over 2, because that's pi, 3 pi over 2 and 2 pi. So that means this is a quarter of pi. It's halfway between pi over 2 and pi. Pi over 4. So it looks like our graph has been shifted pi over 4 units to the right. So we can say our pi is pi over 4, or phi is pi over 4, wait, hang on. Phi isn't a Greek letter P, pi is a Greek letter P. What's a Greek letter? What's phi? Huh. Okay, whatever. Let's ignore that thought for now. All right, so that means we can rewrite this whole equation. Y equals 2 cosine of 2, x minus pi over 4. And maybe you should check to using Desmos. Graph this in Desmos. Make sure that it gives you the curve that we see here. It should have all the same properties. All right, last question, question 3. So we're asked to do a similar thing here. We're asked to determine a sine equation that fits the following graph. Interesting, a little bit challenging. Because we don't see a bunch of periods of this graph. We actually only see a snippet of it. Well, we'll cross that bridge when we come to it. A good first thing to do is always to write a general sine function. So I'm going to write y equals a sine b x minus 5 plus k. And we're going to see if we can pick off any of these as we go. So I'm going to look at this graph, and it looks like it goes from 1 to -1, so it looks like the midline is along here. Kind of like the last graph. Oh, I am totally off center here. Let me just shift this over a bit. All right, I'll make that focused. Okay. So our midline is along the x-axis, just like it is here. Okay. So for our amplitude, that's equal to our maximum value minus our minimum value, and we're going to divide that by 2. If I look at my graph, it looks like the maximum value this wave hits is 1. That's our max. And our minimum value is -1 over here. Those are our maximums and our minimums. That means we've got a maximum value of 1. We're going to take away -1, and we're going to divide by 2. So that equals 2 over 2. So our amplitude is 1. So we're going to take that, and we're going to rewrite this equation. Y equals, oh, I can not even bother writing 1 to sine A. I can just write sine B, x minus phi plus k. All right. So next, we usually find the period. So we could look peak to peak. However, this graph does not give us a peak. It shows that we start at a peak at 0, 1, and then we have this trough at 2 pi, -1. So the question is, where are we going to reach that peak again? Now, as you've probably noticed, these graphs tend to be fixed. They don't change their wavelength within a single wave. So that means we're probably going to be twice as far from 2 pi once we get to the next peak, which is going to be 4 pi. So we're going to expect another peak at 4 pi and 1. And so I can find the vertical distance by going peak to peak. So I can say peak, peak 2, take away peak 1. So it's going to be 4 pi, take away, x value of our peak is at 4 pi, and we're going to take away the 0 here, and we're going to find the difference between them, which is 4 pi. So that is our period. Now, we have to then find our b value, which is 2 pi over our period. So our b value is 2 pi over 4 pi. And we can see some simplification that can happen here. These pi's disappear. We get 2 over 4, which actually is the same thing as a half. So our b value is a half. So we're going to rewrite the equation. Y is sine of 1/2 of x minus phi plus k. I'm going to white that out and make a grand mess of things. This whiteout is awful. Oh. Some user error there too. I should have shaken. Just the worst. All right. Next, we're going to find our vertical shift, which is k. And I look back at the curve, and it looks like, of course, I'm comparing this to a regular sine function. It looks like the midline of a sine function is along the x-axis, and the middle line of this graph is also on the x-axis. It doesn't look like it's been shifted up or down. Now, you might see some differences between these two graphs, but I think you'd agree that a shift from the x-axis is not one of them. So our k value is 0, just like in the last example. So we can take that and we can say y is equal to sine of 1/2 of x minus phi. And I don't even need to say that I'm adding 0. The last thing is our phase shift. Phi. So I might look at a regular sine curve and ask, where does it start? It begins at kind of in the middle of a trough and a peak, halfway, and it's rising upward when it hits the y-axis. And we're just really focused on how this differs from the y-axis. Okay. And so I look on our curve. We say, well, where is it that it seems to be doing that? It is not obvious. However, I can see that it kind of does that here. I have a peak and a trough, and halfway between is where it would cross. It looks like halfway between 2 pi and 4 pi is 3 pi. So it looks like it's been shifted 3 pi units to the right. And so our phase shift is 3 pi. So the whole function could be written as y equals sine of 1/2 of x minus 3 pi. That is our final answer. Now again, you can graph this in Desmo, so take a look at it. Make sure you've graphed the same curve you've represented in this picture. All right, well, good luck with those, and let me know if you have any questions.